Hello everyone, and welcome back to our Python programming series. In previous video we discussed about modules in Python, like what are the modules in Python, why they are so important, and so on. If you didn't watch previous video, please watch it. You can find link in I button, or you can find link in description below. In today's video, we'll be diving into a fundamental concept that every programmer needs to understand: input and output and file functions in Python. These functions play a crucial role in interacting with users and handling data in your programs. So, let's jump right in. A good program should effectively communicate any input in Python from the user and display a result to the outside world. A user can give a program input manually from a keyboard or use data from an external source, such as a file or a database. Python offers us several built-in functions that make it easy to create a program quickly. Two of the most commonly used built-in functions are the input and print functions that are used for frequent input and output operations, respectively. Display the output using print function. We use the print function to display the output data to the console or screen, and we follow the following syntax to do this. Using this syntax, you can pass several objects in the print function separating by comma. Let's see the example. Suppose you have two variables and you want to print the value. You can print like that. Save your file, open your command prompt, type python space file name and press enter. You will see the expected output. As you can see in this example, by default, print separates each object by a single space. However, you can change this by using keyword arguments like sep and end. The sep keyword argument. We use the sep keyword argument, sep equals str, to separate the objects with specific strings instead of the default single space. Here is the example, how you can use sep keyword. Save the open your command prompt, run the Python file to see the result. The end keyword argument. Apart from a single space, print also automatically adds a new line at the end of each output. Using the end keyword argument, we can cause the output to be terminated by str instead of the default new line. For example, if you want to show the values in a loop, you can use the end keyword argument to display them all in one line. Let's print number from 0 to 1, using for loop, and use end keyword in print function. Save your file and open your command prompt, run the Python file to see the expected result. Here is the another example, run the file to see the result. Comment your result in comment section. Files in Python. Files are identified locations on the disk where associated data is stored. They are used to retain data in non-volatile memory indefinitely, example hard disk. Because random access memory or RAM is volatile, means it loses data when the computer is shut off, we employ files to store data for future use by permanently storing it. When we wish to read or write to a file, we must first open it. When we're finished, it needs to be closed so that the resources associated with the file may be released. As a result, Python file operations occur in the following order. 1. Opening a file. 2. Reading or writing a file, perform operation. 3. Closing the file. In Python, there are two types of files that can be handled: text files and binary files. Binary files. The majority of files you use on a regular basis on your computer are binary files, not text ones. That's right, even though it only contains text, the Microsoft Word.doc file is a binary file. There is no line terminator in this form of a file, and the data is kept after it has been converted into machine-readable binary language. Text files. A text file, on the other hand, does not require any special encoding and may be opened with any ordinary text editor. Each line of text in this sort of file is terminated with a special character known as EOL or end of line, which is the new line character in Python by default. Opening files in Python. To open a file, Python includes the open function. This function returns a file object, often known as a handle, which is used to read or change the file. This function does not require the import of any modules. Here is the syntax of open a file in Python. Where filename is the name of the file that the file object has to open, and access underscore mode is the attribute of the file that tells which mode a file was opened in. Default is reading in text mode. Here is the example. The filename is the name of the file with which you want to communicate, including the file extension. That is, if you have a text file named main.txt, the filename is not simply main. It's called main.txt. If you're using Windows, you can also specify the file's actual location, such as c:/project/main.txt. Note, the file must be in the same directory as the Python program file, otherwise, the full location of the file must be written in place of the filename. When we open a file, we can define the access mode. Python understands what you want to do with the file based on the mode parameter in the open function. We specify whether we wish to read, write, or add to the file in mode. We can also choose whether to open the file in text or binary mode. Reading in text mode is the default setting. When reading from a file in this mode, we get strings. Binary mode, on the other hand, returns bytes, and is the mode to employ when dealing with non-text files such as images or executable files. Here is a list of the different modes of opening a file. 1. R. It opens a file for reading only. The file pointer is placed at the beginning of the file. This is the default mode. 2. RB. It opens a file for reading only in binary format. The file pointer is placed at the beginning of the file. This is the default mode. 3. R+. It opens a file for both reading and writing. The file pointer placed at the beginning of the file. 4. RB+. It opens a file for both reading and writing in binary format. The file pointer placed at the beginning of the file. 5. W. It opens a file for writing only. Overwrites the file if the file exists. If the file does not exist, creates a new file for writing. 6. WB. It opens a file for writing only in binary format. Overwrites the file if the file exists. If the file does not exist, creates a new file for writing. 7. W+. It opens a file for both writing and reading. Overwrites the existing file if the file exists. If the file does not exist, creates a new file for reading and writing. 8. WB+. It opens a file for both writing and reading in binary format. Overwrites the existing file if the file exists. If the file does not exist, creates a new file for reading and writing. 9. A. It opens a file for appending. The file pointer is at the end of the file if the file exists. That is, the file is in the append mode. If the file does not exist, it creates a new file for writing. 10. UB. It opens a file for appending in binary format. The file pointer is at the end of the file if the file exists. That is, the file is in the append mode. If the file does not exist, it creates a new file for writing. 11. A+. It opens a file for both appending and reading. The file pointer is at the end of the file if the file exists. The file opens in the append mode. If the file does not exist, it creates a new file for reading and writing. 12. UB+. It opens a file for both appending and reading in binary format. The file pointer is at the end of the file if the file exists. The file opens in the append mode. If the file does not exist, it creates a new file for reading and writing. One new mode has been added to Python 3.x. Exclusive creation mode. This mode is used to generate a file only. The function call will fail if a file with the same name already exists. The file object attributes. Once a file is opened and you have one file object, you can get various information related to that file. Here is a list of all attributes related to file object. 1. File.closed. It returns true if file is closed, false otherwise. 2. File.mode. It returns access mode with which file was opened. 3. File.name. It returns name of the file. 4. File.softSpace. It returns false if space explicitly required with print, true otherwise. Closing files in Python. When we have completed our operations on the file, we must properly close it. Closing a file frees up system resources that were previously associated with the file for I/O purposes. This allows you to manage your resources effectively while writing software with space or memory limits. This is the syntax to close the file object. That's all for this video. We will cover some more practical example in next video. If you found this video helpful, don't forget to give it a thumbs up, subscribe for more content, and hit that notification bell. Thanks for watching, and happy coding! If you have any questions or topics you'd like us to cover in future videos, please let us know in the comments below. Until next time, keep exploring and keep coding.